Alright, hey chem students. Alright, this is the last thing that I want to go over with you guys. I didn't have any time to go over the weekend. I mean, I do expect you guys to do this independently, but I thought maybe I could help. The last sort of calculation, we're going to go into the visible light, or we're going to go into the electromagnetic spectrum. If you remember, I told you that all these guys, radio waves, radar, microwaves, infrared, ultraviolet, X-rays, gamma rays, and the visible light spectrum, rays that come out, they're all different types of light. So when I talk about light, guess what? Guess how fast they're traveling? Are radio waves traveling faster than gamma rays? No, I told you they're all forms of light. Get it? So that means that they're all traveling at the speed of light. And look at this equation here. Now I told you that each wave has sort of a weird kind of relationship between its frequency and its wavelength. Look, the frequency is how often you get waves, right? Like how many cycles. And then as you go out here, the frequency is less because there's less waves, right? In one cycle, let's say, or like there's just less waves, right? In one occurrence. And over here, the frequency of the waves kind of going up and down is a lot higher. So you can see the frequency goes up. But look at the wavelength, the relationship with the wavelength. If your wavelength is really high, that means your frequency is pretty low. So see that as the frequency kind of decreases, the frequency increases. Because look, over here, the wavelength between these two waves is really short, whereas the frequency is really high. So its relationship is the frequency is high, the wavelength is low. This is helpful because look, if I multiply, like let's say X-rays, if I multiply its frequency to its wavelength, it's always going to give me one constant number. And can anybody tell me what that is? Okay, I'll surprise you right now. It's the speed of light. The speed of light is equal to any light or any sort of different like ray or wave, like a radio wave, radar wave. All these guys are traveling at the same speed, the speed of light. All you need to do is you take its frequency times its wavelength. So like right there, that first symbol that I'm to the left right there of my pen, okay, here's to the right, here's to the right, here's to the left, like this symbol right here, that's wavelength. The symbol V is for frequency. So if you multiply frequency times wavelength, you always get the speed of light, no matter what wave it is, okay? Because every wave has a different frequency and a wavelength. But look, if its frequency is super high, its wavelength is super low, 10 to the negative 14th power. Sorry. Over here, it's opposite. The wavelength is much higher. 10 to the second power is much higher, but the frequency is much lower. Okay, so like on a question, on a test, will be like this. If I gave you, let's see, and the speed of light is always this fast. C is equal to about 3 times 10 to the 8th meters per second. Okay. And then the formula is always C is equal to, you have to get used to this. This is wavelength. This is frequency. Okay. So on the test, I might give you this. I give you a wavelength, and I'll pick a wavelength right here from here. A wavelength of 10 to the negative second. I'm talking about like microwave. Some guy between radar and microwaves. 10 to the negative 2. And I'm going to write the units too. So the wavelength is 10 to the negative 2. And we're talking about wavelength. Okay. It'll typically be in meters for length. Wavelength is 10. What is the frequency? Okay. So like for this question here, I give you the wavelength. I don't have a frequency. Figure it out with the speed of light formula. So the speed of light I know is 3.0. I'm going to plug in the numbers times 10 to the 8th meters per second, because it's a speed, meters per second, is equal to like the wavelength, which is just 10 to the negative second meters. And then times V, which is a frequency. I'm trying to figure out the frequency, okay? So what I'm going to do right now is I'm just going to get frequency by itself, but you guys could have done it up here in the formula. Like if I want to get V by itself, I would have just divided both sides by wavelength. So that would have been my answer. I just take the speed of light and divide it by the wavelength to get frequency. Look, that's exactly what I'm going to do here. V is kind of like x, like I'm solving for x. I need to get V by itself, so I need to divide both sides by 10 to the negative second power meters, okay? And then look over here, it's the same thing. So I divided speed of light times wavelength. Look what I'm about to do. I'm about to take the speed of light and divide it by wavelength. Get it? Meters, okay? And then if you guys look at like kind of like how this fraction is written, meters over seconds divided by meters, the meters will actually cancel out. It's sort of like 4 over 3 divided by 4. Okay, the numerator and if you remember your algebra, the numerator in the fraction will cancel out if the denominator way on the bottom down here is the same. Okay, and then you'll just get this will become 1, so you'll get like an answer 1 over 3. Same thing with the units here, meters over seconds divided by meters, they'll cancel out. Okay, now how you divide this, by the way, you can either do it by hand or by calculator. So I would literally just punch in 3 times 0 times 10 to the 8th power divided by 10 to the 2nd power. If you don't know how to do that, you can do it just by hand here. If you ever see 10 just by itself to any power, you can always presume it's being multiplied to 1, okay? You see how this 3 over here is being multiplied to 10 to the 8th power? Now just kind of make this look similar in a way in scientific notation by writing a 1 instead of a 3, you know, times 10 to the negative 2 power. And then what's going to happen is that you take the numbers in front, like the 3 and the 1, like the numbers in front of the 10s, like the 3 and the 1, and you divide those guys. So 3 divided by 1 is just going to be 3. It's the same thing. And what you're going to do is you're going to take the 10s, and what you're supposed to do with the exponents is like exponent 8 and exponent negative 2. With exponents, if they're in a fraction like this, you're going to take 8 and you're actually going to subtract negative 2. So it's going to look like this. 3 times 10, and what you're going to do is you're going to take 8 from the numerator in the exponent, and you're going to subtract negative 2. Because it's the exponent on the bottom, and they have the same base of 10, okay? Each exponent has the same base of 10. Like 10 to the 8th power, 10 to the negative 2 power, okay? That's what I mean by the same base of 10, okay? And then my final answer is actually going to look like this. Because it'll be 3 times 10 to the 8 minus negative 2, that's to the 10th power, okay? Which is true. If I divide by negative, or if I divide by really small numbers, I get a bigger number. I don't know if that made sense, but anyway, right now the only unit that I should have, meters, is just 1 over seconds. Now I think I went over this briefly in the book. Remember, this is just supposed to help you. I'm not supposed to teach this from the ground up. You guys should have already kind of like read this already and just struggled with the information, and I'm hoping that I can kind of clear up some gaps. 1 over s, that means like when we talk about frequency, that's the unit of frequency is cycles over seconds, cycles over 1 second. How many cycles of like cycles is in like that's a cycle, like that's like when you see one full wave like that, that's a cycle, that's another cycle, that's another. How many of these cycles do you see in 1 second? Okay, so that's what, but we don't put cycles over seconds, we just put the number, that's a number 1, okay? 1 over s. So you guys might have seen it in the book as like this, like the answer could be written like 3.00 times 10 to the 10th power s to the negative 1 power, right? That's inverse seconds. Or it could be like this, 3.00 times 10 to the 1 over s. These both mean the same thing. Or what they have it in the book is like this, 3.0 times 10 to the 10th hz. Hz is hertz. It stands for hertz, like HERTZ. And that's the same thing as 1 over seconds, okay? It's just some scientists don't like to say inverse seconds or 1 over seconds, okay? Like inverse seconds, 1 over seconds. They'll just say hertz. I know it's confusing, but 1 hertz is the same thing as 1 over s, okay? So you guys will see the same thing over and over. So on a test, I might ask you to solve for the wavelength, but I'll give you the frequency, okay? So then you just manipulate this equation around, right? So, or sometimes I might even give you like, or actually no, that'll pretty much be it. I'll just give you like a frequency or wavelength, and then you have to solve it knowing that c is equal to 3 times 10 to the 8th meters per second, okay? And if you and by the way, scientific notation, if you ever multiply scientific notation, like let's say 1 times 10 to the 4th, and then I have to multiply that to like 3 times 10 to the 8th, like I don't know if you ever will, but if you ever had to do that, again, if they have the same bases, like times 10 to whatever power, I just take the numbers in the front, 3 and 1, and I multiply that, so that'd be 3. Okay, and then what I do in this case, since they're not being divided, the 10 to the 4th power, the times 10 to the 8th power, the base stays the same, but the exponents add this time, okay? 8 plus 4 is 12, okay? So that would be my answer for this. Over here, I had to take the exponents, and I had to divide them. 8 divided by negative 2. Or you can just punch it in the calculator, okay? So the calculator works just fine. And again, if you ever see like 10 to the negative 14th, and there's no number in the front, just put 1 times 10 to the negative 4. It's the same thing as just saying 10 to the negative 14th, okay? So I hope that helps. That gives you a little bit of an idea of what to do. Still go through the calculations in the book that go